Yes, great. So I will speak today about economic and labor market impacts of migration in Austria using this agent-based model, which I just introduced. And so this work has been done in quite a large group of authors under the Austrian Science Fund project, which we actually working on together with CEMI until last year. So the project on our side finished this year, and now we are actually still in a stage of publishing the results. So this paper is not yet published, it's submitted and under review. So in the end of the presentation, you will have a link if you would like to read more about it. So the outline of my presentation, first I will speak about motivation, why actually we started this project. Then I will briefly speak about agent-based modeling of economic systems, so a specific accent on economy. Then I will introduce our IASA macroeconomic ABM, describe its mechanisms and calibration, in particular for the goals of the project. And then I will also introduce the results produced by simulation of this model in this particular project. So the project was motivated by need to study economic effects of migration, in particular in Europe and in Austria. Large migration shock, they have led to increasing political debate, how to manage them. So either migrants should be accepted, or they should be deported, or whether there should be any aid to the countries from migration actually are coming from, whether aid should be deployed, or whether migrants should be given various benefits when they arrive. And of course, it's the scale and the composition of migration shocks. It created a great uncertainty, both on the economy and in society. And of course, it also led to a polarization of a debate. So the rise of right-wing parties and really heated discussions in the parliament about how migration should be managed. So, and this actually, for us, for scientists, makes a need to develop tools to inform these stakeholders and policymakers about most likely economic and social consequences in migration to foster evidence-based decision-making. And in particular, so we, since we developed actually the model and the scenarios before 2022, yeah, now the situation has changed a bit also in terms of migration to Europe. We actually based our estimates on a previous large-scale migration crisis in 2015 and 16, and we can see actually that the number of refugees who have been granted asylum since 2015 only increased from year to year, a cumulative number. And then we forecasted a scenario so that in 2022 about 250,000 migrants would enter Austria seeking for asylum. And in reality, actually, this number was really not far away from reality, because both Ukrainian refugees and also migrants from other countries like India, Tunisia, and of course still from Afghanistan and Iraq, overall for 2022, the real number was about 200,000. So our scenario, despite we made it quite extreme, was not far from reality. And the idea was that using this migration scenario and the model, that we would like to display the economic consequences of a macroeconomic level, like typical indicators like GDP, unemployment rate, and government debt, and as well as consider heterogeneity, for example, by economic sector, so how employment in particular sectors will be affected, and socioeconomic status, like how many women, how many men will be affected, to allow actually studying distributional impacts of migration. And for this purpose, we also utilized microdata provided by Statistics Austria and by Eurostat. So some of the data was in public access, some of the data we have to purchase. Yeah, so we injected this data in the existing macroeconomic model, and then I will briefly speak. Probably, yeah, most of you know all of this, but I'm not sure about composition of the audience. So, yeah, we believed actually, in that ABMs are really useful for studying economic systems, and for the purposes of a study, we developed a model actually consisting of millions of agents. Basically, every person in Austria was a single entity in the model, an agent, and also we implemented bounded rationality in our model, and the goal was to depict these emergent patterns like GDP or government debt arising from a complex interactions on a micro level, and of course subject to this uncertainty caused by different scenarios. And actually, agent-based modeling is a relatively new way to model complex economic systems. So as you can see on the graph on the right, its share in the total publications is increasing from year to year, but we can see still in the economics, econometrics, and finance research area, the share of papers using ABMs is less than 1%. So it's really like fractions of percent. But this, of course, takes all the papers, macroeconomic, microeconomic, statistical. But at least we see, the increasing trends that, in the last 15 years, the share increased almost threefold. And it's believed, and also we believe that, of course, ABM has a potential to be more realistic models of socioeconomic systems, because the existing models, they have some drawbacks. So in particular, in normal times, with statistical and macroeconomic models, they tend to work pretty well, but in abnormal times and shock times, they usually show unsatisfactory results. And for example, it was clearly shown in the recovery from Great Recession, so 2008 and 2009 financial crisis, that, for example, in the UK, the models, several models tested, like the ensemble of the models, and the reality, how actually the shock developed, and we see that none of the models was capable of predicting this shock, even after the shock was injected in the model. And that's why the ABM actually can be a promising direction to complement the existing models. Of course, they cannot substitute them completely because of different scope, but they can complement them by introducing heterogeneous agents. So in particular, firms and households with a really detailed level of heterogeneity, and also relaxing the rational expectations, so typical assumptions like maximizing some utility functions. And also there's a overview of how different macroeconomic and agent-based models relate to each other. And what we have been developing, we call it agent-based models of next generation. So compared to existing agent-based models, which have been produced already for a while, so since maybe about 20 years, our goal was to move from more or less exploratory models to large-scale models based on real data, so that we can utilize the increasing availability of microdata produced by statistical agencies like Eurostat, Austrian Stat, probably, I believe, Eurostat also produces such data. And also much not only stylized facts, typical textbook facts from macroeconomic studies, but also much historical evolution of variables, so to reproduce basically the historical time series. And of course, this, despite all the promised advantages, is actually quite a huge undertaking to develop such a model, because of large complexity and large amount of data needed, and of course still a lot of missing data, which can also have to be imputed somehow in order to make a full-fledged calibration of such models. And this, I think, is a really nice chart from one of the papers that shows the realm where which models they operate, which they're capable of supporting. And as we see that agent-based models, they excel in area of internal consistency and heterogeneous agents, while like DSG models are also internally consistent based on macroeconomic theories, but usually they have one or several representative agents. They like really these details of tracing each separate household or each separate firm. Of course, there are some hybrid models which have some groups of households or groups of firms. I think actually at SEMI such model was developed back in 2006, even, as I remember. But what agent-based models, they still lack is externally consistency is actually reproducing this historical data patterns, which really statistical models are good at. And our goal is actually to shift this, to increase this realm that they can also make the model externally consistent. And lastly, I would say here about different challenges which these models have. So statistical models, they usually really reproduce well the time series. But again, if we go back for some shocks, so abnormal behavior, then they are really weak in predicting and explaining economic events which happen out of sample. And the DSGE models, they use economic theories, so micro-founded behavior of agents to explain the economic events, but they usually, simply because of a methodology of the requirement to have imputed equilibrium on the model, they usually tend to be smaller models with fewer variables. So it's typically models containing representative agents. While ABM, they can combine advantages of both statistical models, so having large-scale data, and also still use sounded foundations of economic theory. And they can be large-scale, so infinitely, basically only constrained by computational power, and they can compete with other models with out-of-sample prediction. So basically predict the historical time series, including the shock times. And based on all of this, long year discussions, so we have been developing it, I think, for about 8 years, this model. So now it's more or less a settled model, which we expand. And now I will cover just some basic details of this model. So who are the agents in the model? So the agents are non-financial corporations, basically firms, and including also companies and self-employed people, so one-person enterprises. We also have financial corporations, so banking sector, and additionally there's one representative bank, as well as a central bank, and household sector. So these are individuals, people split by socioeconomic status, gender, and also employment status. They can be employed, unemployed, or they can also invest, so develop their own firms, and they can be also inactive, so they're not participating in the labor market, but they receive social benefits from a government. And finally, central government consisting of general government consisting of central, state, and local governments. So also like for Austria, for example, it's important because local and state governments play a role in supplying, for example, migrants with benefits, and from state to state there can be different implications. And then, so some more words about the mechanism of ABM. So the firms, they operate in 64 sectors, so with a typical input-output structure, motivated by the NACE structure, commonly applied in European statistics. And so they produce goods and services, and they use labor, capital, and intermediate inputs from other firms. So there's a production function describing all of this. And the agents, both firms and consumers, they're bounded rational, so they don't optimize explicitly any utility, but rather they form expectations about future development on the markets using adaptive learning. So each of them have a simple prediction model, econometric model behind them to develop a heuristics, which actually is based on observed growth rate and observed inflation. And the markets, so they operate in the form of networks, and it's based on quite standard search and matching process. So the firms are randomly visited by consumers, and the likelihood that actually consumers will buy something from this firm, it correlates negatively with the price and positively with the firm size. So typically, for example, if we go shopping, probably we will go to a larger shop and buy cheaper goods if it's available. But of course, there's also some uncertainty, so to incorporate some irrational behavior. And because of this, sometimes there is no market clearance, and inventories or involuntary savings, for example, that people they don't spend all their income in a particular model time step, and they save because of this. So this can happen because of this process. And similar, the labor market is also modeled using a search and matching product, but basically because instead of prices on the market were wages suggested by the firms, and the individuals they can choose their employer based on the wages. And demand actually of funding for firms and investment is based also on expectations and expected future cash flow. So firms can predict what can happen, but of course their predictions are not always not always consistent with reality. So a shock happens, of course their predictions are not valid, and then we can really see how the crisis is developing. And yeah, we also have loans from banks which can be granted to the firms based on typical financial conditions. And finally, the general government acts as a consumer. So basically, it's just also buys goods and services from all of the sectors according to a input-output structure, and as redistributive entity in the sense that it collects taxes from individuals and firms and pays out social benefits, unemployment benefits, and subsidies to the firms. So we include all sectors, basically typical for national accounting. It's financial, non-financial sector, household sector, and government sector, and we populate them according to the census and labor force survey data. And we can, based on this, produce a complete GDP entity, so formed exactly as in national accounts, including all transactions and products, non-financial assets, and distributive transactions like unemployment benefits or social benefits. And as I said, yeah, we, instead of rational expectations, we implement adaptive learning. And we have multi-sector production network calibrating to IO tables. And all these markets, so they are decentralized, allowing for trade frictions. And also such structure allows for non-linear responses, and it may also well happen, we showed it in some test runs, that even without exogenous shocks like migration or natural disasters, they still can, because of the complexity of the model, some endogenous crises can arise, so similar to 2008 financial crisis. And also we validated this model comparing to DSG models and econometric models, and we showed actually that our model actually exceeded these models in the out-of-sample predictions. But this has been done in a previous paper, so for migration, we actually have to develop our model additionally to increase its realism, and also to include the heterogeneity of households, which was lacking in the original version of the model. So here, yeah, I will also say a couple of words about calibration for Austria. Here we can see like these blue dots on the map is actually location of firms, and location of firms in Austria, in Vienna, and in the center of Vienna. So we have really data about all firms registered in Austria with their balance sheets, so we know their profits, how much wages do we pay to the employees. Of course, this data is subject to some imputation because of confidentiality, but yeah, this data is from trusted source, so we have to purchase it actually to use in the model. But also we use some publicly available data like input-output tables, government statistics and national accounts, and also additional guidelines and regulations, for example, to calibrate financial and banking practices, like how, for example, the loans are provided to the firms. And then I will speak more about calibration of population model over ABM, which we required for modeling migration. So here we see that in Austria we have we modeled actually only working age population, so we didn't model children younger than 15 years old. So overall about 7 million of agents, and we split them into citizenship, so they can be Austrians, they can be EU but non-Austrian, or all other countries. So we have 2 genders, we have also 3 activity statuses, So employed, unemployed, or inactive, and both employed and unemployed agents, they belong to one of the 64 industries. So in the case of unemployed, it's actually this the last industry where they used to work before becoming unemployed. And overall, so these combinatory combinations, yeah, they give us 774 cohorts, and in each cohort there's certain number of people corresponding to the actual data in 2019. And then in order to model labor market transitions, so we used another interesting data which contains all the interactions on the labor market. So how different groups of individuals, again, split by citizenship, sex, and activity status and industry, how do actually they change their employment career. So for example, we can know how many farmers working on the farm in 2018, they become a job in IT sector in 2019. Of course, it's a small fraction, yeah. But also we can see that in some crisis years, somebody working in I don't know, real estate sector has actually to switch to hospitality sector. So all such transitions are taken from a data. And that's why we can estimate probabilities for each individual to make a transition to a corresponding industry. But of course, these transitions are also subject to the labor market negotiations. So as I said before, based on the suggested wage, the agents, they can choose the most attractive employer. And finally, we calibrated migration scenarios. So migrations who are coming to Austria. We split this shock into 6 quarters. Overall, 250,000 additional agents were added. And so citizenship were obviously all from other countries, not from Austria, not from EU, also 2 genders. They can either unemployed or inactive. And if they're unemployed, so we use some survey data in order to understand in which sectors actually these people have education, or if such data were available, in which sector they would like to have job in Austria. So that's why this additional cohort, 140 cohorts of migrants, they were added to the model in the migration scenario. And the model was actually implemented in MATLAB, and we strive to implement the model as close as possible to its documentation in terms of like mathematical equations. So I really try to make it one-to-one correspondence to documentation. And here, so you can scan these 2 QR codes. So one of them is actually a baseline model code, not a migration, because it's not published yet. So it's still not published also in the public access. But the baseline model calibrated for Austria and the underlying data, which is available for free, it's on Zenodo, as well as a documentation for the model, and also the model paper published in European Economic Review Journal. So it has been also published last year. So those of you who would like to really dive into details, please use this QR code. So you can also find it based on our names. And also additionally, there was a distributed memory parallel implementation developed with Japanese colleagues. This was, of course, striving to increase the speed of the model, to run it on clusters, and with a potential to model larger populations of agents, like, for example, develop a model for a whole EU. So we're really we have 500 million agents, individuals, and additional several million firms. So this is really computationally intensive task, and now actually we are still working on it. And finally, about some simulation results for migration scenario. So first, the typical macroeconomic indicators. So we simulated our model for 5 years with a quarterly time step. And we can see that actually the different developments, like GDP in migration scenario actually increases compared to baseline scenario. And these gray shades actually they denote the uncertainty, because each model we run, each simulation, each scenario we run 500 times using Monte Carlo approach. And of course, this created uncertainty. But the mean actually of this model ensemble is this straight line with migration scenario, and baseline scenario is a dashed line. And on the other hand, we can see that despite increasing GDP, the government debt has slightly increased compared, like it decreased actually through time, but compared to a business as usual scenario, it is larger than it can be. But on the other hand, we can also see that the GDP growth rate, it initially after 1 year after migration shock, it increased, but then it starts to decreasing, and actually in the end of the simulation, it was even lower than in the baseline scenario. And more interesting results are for unemployment rates. So here we see that initially after the shock, the unemployment rate has increased, and then it started to stabilize, but still was actually larger than the unemployment rate in the baseline scenario. But also we can see that this 2 percentage points difference. So it's like when we first simulated the model, we realized it's actually quite small if we imagine that such a large number of migrants, 250,000 arrive, so only 2 percentage points of unemployment. But if we go deeper in the details, there are really significant differences with the composition of this unemployment. So this is really like the key feature of our ABM. So we can go really deep into certain cohorts. For example, we can assess the unemployment only for natives, for Austrians, and separately for men and women. And we can see that for them, of course, yeah, the growth of unemployment was the smallest, only like in 5 years, only 0.5%. For EU migrants, EU citizens living in Austria, it was slightly larger, both for men and women. But if we go for other country cohort, and especially for refugees cohorts, so existing refugees, we are actually complemented in a sense by newcoming refugees. And we can see that especially for men, unemployment increased in 5 years up to 26%. And in the second year, it was almost 50% larger. So these were really significant differences. And of course, we didn't model any social effects in the model, but we can anticipate that if we have really a large unemployment in these groups, this can also cause social tension. And finally, the ABM also allows us to study the differences on a sectoral level. So we have different sectors here in the left-hand side. And we can see that for some of the sectors, like administrative and support activities, accommodation and food services, so actually the services where typically many migrants work, they have the largest increase in unemployment. But in some sectors, so typically sectors connected with real estate, with actually supplying real estate, communal expenses like gas, electricity, and also with financial services, because of the migration shock, the unemployment actually decreased slightly, but decreased. And we can see here in more detail for all 19 sectors. So as I said, like in the model, we have 64 sectors, but just to visualize, we used 19 sectors where some of the sectors are aggregated. And again, here we can see that some of the sectors are most heavily affected vis-a-vis N and I sector. So N is administrative services, and I is accommodation and food services, so like restaurants, hotels. And here we see again that in some years, the unemployment growth reached 10%. But actually going closer to the end of the simulation, it slightly decreased. And also we can see the number of unemployed people. So this is also important for policy planning. So we can really see how many people are unemployed in each sector. And this can potentially help policymakers to develop targeted programs at the basically employment services to foster education or reskilling of these people, so they can really find employment quite soon in other sectors. And here I presented still quite aggregated results, but we can go even deeper. So we can see, for example, concretely about women refugees working in the food sector. So we can basically make a cross-tabulation on this table and on this table, and we can really go deeper and realize what are the needs of these concrete cohorts of people who are the most vulnerable, or who vice versa actually are the most secure. Obviously, as you can see here, the communication sector, the education sector, quite surprising here, they are doing quite well. And so this shows that migration shock can also benefit some branches of the economy, but of course, using these benefits, there are also all potential challenges in other sectors or other population groups should be solved. here are some references. So if I share this presentation, you can also have a look at them. And finally, so this QR code will lead you to a paper preprint at SSRN. So this is not yet a peer-reviewed paper, so we're waiting for review about half a year. But what the current version, you can access it for free and read. And if you have any questions, please contact me at any